and welcome to our last Book Sandwiched In presentation for 2019. I'm Barbara Cook, co-chair with Amy Towery of the series. As always, there are refreshments at the counter and at the table at the side of the room, and bread is at the back of the room, again manning the membership table. If you haven't signed up for Friends membership, please feel free to do so today. On your chairs, you may have found an additional handout, something new. Gary Fitzpatrick and his wife Janice have been very kind and have developed a list of additional resources related to our presentation today. So I hope you'll take note, and if you like, take that list with you and perhaps pursue the topic further. Our book today is The Hidden Life of Trees by Peter Wohlleben, and our presenter is Akiva Silver. Akiva has lived in Spencer, New York for the past 10 years and has studied wilderness survival. He currently owns and operates Twisted Tree Farm and grows 20,000 trees a year in his nursery. In addition, he has written a book called Trees of Power, which has been published this winter. Welcome, Akiva, to Books Sandwiched In.
Hello, everyone. Thank you for having me. Everyone's been so nice since me and my son got here, and it's really nice to be here. So I've given a lot of talks over the years about trees, and it's always been about trees that I'm working with, or trees that I use, or trees that are part of my life. And I've never given a talk about someone else's work, which is what I'm doing today. So I hope it goes well. So this book came so highly recommended to me for like the last few years. People keep telling me, you gotta read this book. So like where I'm from, everybody just kind of calls me the tree guy. That's all I ever talk about a lot of the time. And I'm like, oh, the tree guy, you gotta read this book, Akiva. And I just was like, yeah, one day I'll read the book. And then my dad finally gave me a copy, and it was my dog chewed the corners off. And I just kind of set it there, and then they asked me to do this presentation, so I finally read the book. And I have to admit, I thought it was going to be one way, and it was totally different than what I expected. So I think just to back up, it's important to introduce myself and then to speak a little bit about who the author is. Because it seems like a tree guy that I would read this book and I would just be like all about it. So for me, I have this really deep belief that people belong in nature, that we're part of nature, and that we need to be interacting with nature. And that is how we can create the healthiest, most abundant ecosystems ever. And that's like my whole philosophy, my whole work. I raise all these trees in my nursery, and my work is to really encourage people to plant trees. And I do a lot of work to repair damaged ecosystems. I just love you go out into the world and it's like most of it's been torn up, right? There's parking lots, there's gravel pits, there's developments, there's lawns with compacted soils. The whole world has just been transformed. And so my work is all about healing some of the deep scars that have happened and bringing back bird populations and mammals and insects and all of it. And so that's where I'm coming from. I just love the damaged ecosystem and coming in and having people start to interact with it in a way that we can then increase wildlife populations, even in suburbs and cities and stuff like that. But the author, he's totally different. He's a German forester, and I think he wrote the book in German, and then it was translated into English. And in Germany, forestry is it's an exact science. So the way we do forestry here is really different. They go out in the woods and they mark trees and thin them out. It's all wild, and they're just, it's not there's so much woods here that even though it's been cut and grown back, it's still like pretty wild. And so people just have a really different attitude, and there's so much here that people can go into the woods just with a truck, take whatever they want, and it's pretty messy, right? It's not like anybody's keeping track of a lot of it. But in Germany, it's a science, and the way they manage their forests there is kind of the way we manage cornfields. It's like the trees are this far apart, and they're planted this species in huge blocks, and then at age 20 we thin them out, and at age 40 we thin them out further, and at age 80 we harvest all of it and then replant it. And it's all done with this like exact science, and it's all highly mechanized. They use tree harvesters instead of like guys with chainsaws walking around in jeans. They have like giant tree harvesters, kind of like, there's pretty crazy images if you were ever interested in seeing how tree harvesters work. It's like a giant pair of scissors that just grabs a tree. So they have it is a totally different thing. So he's coming from that world, and I'm coming from this world. And so he was studying forestry in Germany, and then what happened was he started off in the mainstream, and then he started to kind of have these realizations about the forest and about trees, and he started to believe that trees were sentient beings, and that kind of made it so it was really hard for him to continue his work as this like scientist forester. And he started really working with old growth forests, and almost the whole book is about old growth forests and like untouched perfect ecosystems that haven't been spoiled by the hands of people. And he talks about how those systems function and how they can come to be. And his whole philosophy throughout the book is hands off. He's really about like hands off. And my whole philosophy is hands on. And so I found a lot of things in the book. I was just like, what? How can you say that? Like I wanted to write him a letter a few times. But at the same time, his work so it's called The Hidden Life of Trees, but then the subtitle is What They Feel and How They Communicate. And that part of it was really fascinating because he actually uses these a lot of scientific studies to explain like how they're showing that trees have things like memory and hearing. And it's like pretty cool. I heard about some of that stuff, and it was really interesting to hear his explanations and referencing some of these different experiments that have happened. So anyways, there's like two sides of the book like that. There's the side where he's talking about like how these trees are totally just as alive as we are and just as sentient as we are, which I found really beautiful, and I'm sure some people would be like, what? Are you crazy? But that part didn't bother me. It was more his hands-off approach that bothered me. But then he has the table of contents. So in the table of contents, there's 36 chapters in a 245-page book. So the chapters are really short, and it's really set up as like very easy to read. You could sit down for 5 minutes and read a chapter, and it's all written in prose. So it's not like I wrote a book and it's totally different. My book is more like it's like blocked in outline with a lot of how to do stuff. But his is more for like someone who just wants to like curl up on the couch and read a cozy book and hear some interesting ideas. But throughout this table of contents, he just like jumps around back and forth, a lot of the points he would make in the first chapter, and then in the 9th chapter, and then the 17th chapter, and he would just keep coming back to them, which I found like a little bit repetitive sometimes. But overall, it was. I'm really glad that I read the book because some of his ideas were very exciting, and he writes really well, yeah, there was some really fascinating things. So I'm just gonna go through some of these parts of the book, and I was gonna talk about some of the parts that I found most fascinating and some of the parts that I found most disagreeable. And so I'll just read some really short passages. So in the second chapter. I don't know, how many people read the book, just out of curiosity? Thanks, all right. So in the second chapter, it's called Communication, and he's talking about how trees talk to each other. And I have known for a while that trees communicate with each other, and science has completely accepted this fact. In fact, the way I first read about it, I was kind of expecting him to talk about that, but he didn't. He talked about it in a different way. So the way I first heard about trees communicating was there was populations of oak trees that would be hammered by gypsy moth caterpillars, and the oak trees would respond by releasing this substance called jasmonic acid into the air, and the jasmonic acid would travel sometimes hundreds of miles through the air and reach another stand of oaks, and the other stand of oaks would receive this acid and they would take it as a message. And the way they know that is because when the jasmonic acid would arrive, they would triple the tannin content in their leaves, making themselves unpalatable to the caterpillars. And so he also talks about different ways how trees communicate. So I'm just going to read this paragraph. They also warn each other using chemical signals sent through fungal networks around their root tips, which operate no matter what the weather. Surprisingly, news bulletins are sent via the roots, not only by means of chemical compounds, but also by means of electrical impulses that travel at the speed of 1/3 of an inch per second. In comparison with our bodies, it is admittedly extremely slow. However, there are species in the animal kingdom, such as jellyfish and worms, whose nervous systems conduct impulses at a similar speed. Once the latest news has been broadcast, all oaks in the area promptly pump tannins through their veins. So it's like really amazing to think about. The trees they're sending stuff through the air and through the root systems, and they actually have like electrical impulses moving through their body. And they in some of the parts of the book, he references these studies where they measure the electricity moving through the trees, and I thought that was so crazy. I never imagined that. Like, the way I think of trees being alive, I don't imagine, like, I know humans have electricity, like it's measured in your brain and stuff. I didn't realize that trees did that too. But he goes on to like further describe like how deep this communication is. So trees communicate by means of olfactory, that's the chemicals being released into the air, visual and electrical signals. The electrical signals travel via a nerve cell at the tip of the roots. But what about sound? Let's go back to hearing and speech. And then he actually shows like how they communicate by sound. They're measuring, the scientists' measuring apparatus was registering roots crackling quietly at a frequency of 220 hertz. Crackling roots? That doesn't necessarily mean anything. After all, even dead wood crackles when it's burned in a stove. But the noises discovered in the laboratory caused the researchers to sit up and pay attention. For the roots of seedlings not directly involved in the experiment reacted. Whenever the seedling roots were exposed to the crackling of 220 hertz, they oriented the tips of their roots in that direction. That means the grasses in this experiment were registering this frequency, so it makes sense to say that they heard it. And he kind of does this throughout the book where he uses language that's like, I think the word is anthropomorphized. He really is like not shy about it at all, which I found refreshing, but I can see how other people would find that annoying. And then chapter 3, it was called Social Security, and I thought that was a really great chapter, and he talks about how trees, so we have this paradigm that we think trees are all in, nature is all in competition, it's survival of the fittest, right? And that's the belief system. It's not necessarily reality. And humans, sometimes people think humans are in a system of survival of the fittest, but other people think they're actually not. It's a system of cooperation. So we have churches and communities and tribes and villages, right? Families. And he talks about the trees being the same way. And he talks about how the mother trees, like a tree that creates its own seedlings, will actually recognize its own seedlings and feed them sugars through the roots to its own seedlings over other trees. And I thought that was really, really surprising. Like, I have always known, well, not always, but I've known for a while that trees communicate with each other and that they'll help each other, and they'll actually form graft unions with their root systems and help each other. But I didn't realize that they actually recognize their own genetic offspring. I thought that was really amazing. There was like a lot of amazing things throughout the book. So I'm just going to list a couple other amazing things that he listed here. So there's another chapter called the Tree Lottery, chapter 6, and in that one he's talking about like the odds of becoming a tree. And it seems like there's a lot of seeds produced by a tree, and what are the odds for each seed? It's like us. I had somebody tell me this recently. I was feeling kind of sad, and he was like, "You are a winner." I was like, "What do you mean?" I don't know. He's like, "No, you're a winner." He's like, out of like 300 million sperm, you made it. You're a winner. And I was like, all right, we're all winners. But when he talks about the odds for a tree, it's like even more incredible. So the whole book has these like little like snippets of information peppered throughout it. So he says, let's calculate the odds that await tree offspring in the least favorable circumstances. Let's consider the poplar, which is a type of tree. The mother trees each produce up to 54 million seeds every year. How their little ones would love to change places with some other species like the beech. For until the old ones hand over the reins to the next generation, these trees produce more than 1 billion seeds. Wrapped in their fluffy packaging, these seeds strike out via airmail in search of new pastures. But even for them, based purely on statistics, there is only one winner. So the way, if you think about the population of trees in the world, the way it's kind of explained is that, sorry, I have a cold. Each tree only has to produce itself one time to maintain population. So let's say there's like 9 billion oaks. For there to continue to be 9 billion oaks, each on average would make one more tree. So if a poplar tree is making, 54 million seeds a year, and it does that for X amount of years, it makes 1 billion seeds. Only one of those out of its whole life is actually going to become a new one. So the book has so many cool things like that. I'm going to read a couple other really fascinating facts. So then he talks. This is like a fascinating fact, I thought. He's talking about trees on the tundra that grow really slow. For those of you that don't know, the tundra is a region of land in the north, but it's like the limit of where trees can grow because it gets so cold up there. I'm talking about dwarf trees on the tundra, which are sometimes trampled to death by travelers who don't even know they are there. It can take these trees 100 years to grow just 8 inches tall. And I was like, this is ridiculous. I'll read 2 more interesting facts, and then I'll get back to like the rest of the book. And then in page 132, he's talking. The chapter's called "Motherships of Biodiversity," and he's talking about all the life that one tree supports. And he talks a lot about that. He talks about how we're so obsessed with megafauna like big bucks and bison and hawks and eagles and lions. But he talks a lot about how important all the little tiny creatures are, the little things you can only see with a microscope that live in the soil, or just little things that chew on leaves, right? So in this one, he's talking about a study where people went up into the canopy of trees and they look at what is chewing on leaves, what is living in the canopy, right? So they go up into this one massive old beech tree, and the results show how species-rich life is way up high. The scientists in this experiment counted 2,041 animals. When he says animals, he's talking about insects too. 2,041 animals belonging to 257 different species, and that's just in one tree. And then there's one more really cool fact I was going to share. And that's he's talking about light and how light is gathered. The chapter is "Let There Be Light," and it's talking about how much light the forests actually capture versus fields. To grow its trunk, a mature beech needs as much sugar and cellulose as there is in a 2.5-acre field of wheat. That's just one tree producing as much cellulose and sugar as a 2.5-acre field of wheat. And of course, he's talking about massive old-growth forests, and he doesn't consider forests mature until they're like 500 years old. And he really doesn't think those forests should be planted. He thinks if you plant trees, the roots will be like, they'll never recover. He goes on and on about how bad it is to plant trees, which kind of drove me crazy. But, anyway, getting back to the book, I'll try not to jump around too much. But so in chapter 8, on page 48, he references this Dr. Monica Gagnano. She's like, if you're really into trees, she's like the most awesome scientist today, and she's done all these experiments that have just blown people away. There's an episode on Radio Lab. I don't know if anybody listens to that podcast or radio show, but it talks about her work, and she's just like shattering people's belief systems. And what she is doing is she's conducting all these experiments showing that trees have memories and they have hearing, and it's like, it's so, you hear the experiment, you're like, really, that's crazy. But he references her in it, and he does this, he references it in this experiment that it's like, I was like, it didn't seem that exciting to me. So he used this experiment where she had the mimosa trees. How many people know what mimosas are? All right, they're the ones that fold up their leaves. So he showed how they can react to being with water dropping on them. And I was like, everybody knows that. But she did all these other experiments that I was really bummed that he didn't reference. So like one of my favorite experiments she did that I was really expecting him to talk about was she took all these plants and she put them in a dark room, and then she would take a fan and have it blow from just one side of the room, and then about 3 seconds later she would put a grow light on that side of the room, and then these plants would all turn towards the grow light. You know, everybody has seen plants reach for light, and she did that every day for like 10 days, and then she just turned the fan on and didn't turn the light on. And it's kind of like the same theory behind Pavlov's dogs salivating when they hear the dinner bell. And so she turned the fan on, and all the plants would turn and look for the light, but the light wouldn't be there. And they like she did all this stuff to show like how long they can remember something for. And I thought he was going to talk about that, but he does talk about how they have memories. Moving on to the book. Chapter 9 was a really good one. It was called United We Stand, Divided We Fall. And it's all about the fungal network that exists in forests. And I knew quite a bit about this before because of my interest in trees. But basically he explains how the whole forest floor in an undisturbed forest is connected by an internet of mycelial networks. This is like the strands of fungi, and the fungi. There's mycorrhizal fungi. Mycorrhizal means myco means mushroom, and rhizal means root. And so the mycorrhizal means is mushrooms and roots. And there's endomycorrhizae and ectomycorrhizae. Endomycorrhizae actually enter into the root. They go into the root system, and they're inside the root. And they will actually feed the tree different nutrients from the soil, and the trees will share sugars and stuff that they've gathered from the sky with the fungus, and they form this partnership, but it extends from tree to tree, and it's like a whole network, and the whole thing is tied together. So one fungus might run into the roots of many different trees across different species. And he explains that in a beautiful way. I always found that to be one of the most fascinating aspects of the forest. And it's kind of cool to know that those fungal networks only exist in places where fungus can thrive and live. And in our forests, it's kind of just the way things are. But earthworms were introduced to this continent a while ago by accident. They're not native here. And our forest floors used to be like duff, like this thick. It would just be like mats of leaves just filled with these mycelial networks of mushrooms, right? It would just be filled with that, and the trees' roots would go back and forth through that, and it was this huge sponge that they all sat on. But then with the introduction of earthworms, they actually just chew those leaves right up, and they chew the fungal strands too. And so most of those networks have actually been destroyed in our forests, and the trees are, I don't know, I'm sure they suffer for it. All right, so chapter 11, I'm just going to keep moving on. Trees aging gracefully. He kind of like, I'll just read this passage. The biggest difference is simply the vocabulary we use. This is more the anthropomorphizing. The skin of beeches, oaks, spruce, and company is called bark. It fulfills the same function and protects trees' sensitive organs from an aggressive outer world. Without bark, a tree would dry out, and right after the loss of fluid. So I forgot why. I'm sorry, I actually forgot why I read that passage. But he kind of like compares. Oh, I do know. He's comparing humans to trees throughout the book, and I'll give you another example of that. So František Baluska from the Institute of Cellular and Molecular Botany at the University of Bonn is of the opinion that brain-like structures can be found at the tips of the roots. In addition to signaling pathways, there are also numerous systems and molecules similar to those found in animals. When a root feels its way forward in the ground, it is aware of stimuli. The researchers measured electrical signals that led to changes in behavior after they were processed in a transition zone. If the root encounters toxic substances, impenetrable stones, or saturated soil, it analyzes the situation and transmits the necessary adjustments to the growing tip. The root tip changes direction as a result of this communication and steers the root around critical areas. So he's really like throughout the book, he just keeps coming back to this like, they're just like us. They're just like us. They have brains. It's just not the way we think of it. They have hearing. They have memory. I thought that part was like probably my favorite part of the book. Before I go on, I think I want to talk a little bit about some of the things that really like kind of made me be like, what the heck? On page 80, he says, he talks about how, so in the oldest European forests, they've all been cut. But they didn't cut trees the way we cut trees. The way we cut trees today is like, I cut a tree, I got it, on to the next patch. But back in the day, especially like around the Ice Age, and especially in Northern Europe, they had this tradition called coppicing. And coppicing is a beautiful system that is now gaining favor today, especially when people are trying to develop more sustainable systems of harvesting carbon. So coppicing is where you cut a tree, but you only cut it while it's fully dormant, and you actually protect it from animals afterwards. And so you cut it, and then you expect it to grow back from the roots, and then you put it on a cycle. And maybe you coppice it every year because you want straight shoots for basket weaving, or you coppice it every 7 years because you want stuff like that big around for fuel wood, or you coppice it every 50 years because you're looking for timbers. But almost all the forests of Northern Europe were coppiced by people, and I always thought that was like such a cool system because the roots stay intact, and you're able to just harvest and harvest and harvest in the spaces. And some of these trees in Europe have been coppiced for like thousands of years. It's really amazing, and they're still there. And you can see like pictures or videos of it, and the trees, one tree might be as big around as this room, but the center is hollow, because if you cut down a tree, all the shoots come from the outside, and they just kept doing it, and these rings got bigger and bigger. But then, so he's like, what a shame, the trees will never be untouched by humans, they're like disfigured forever. And he says, coppicing was popular because people were so poor in the old days. And I'm like, I don't think so. I think people coppice because it makes a lot of sense. And I actually maintain stands of trees that I coppice on a regular rotation. And I don't do it because I'm poor. I do it because I feel like it makes a lot of sense as far as being able to harvest wood over and over and over from the same root system. Anyways, I don't want to be too critical. So there's like another, just like some of his language, on page 91, he says, he's talking about creating old growth forests. He says, to make it possible for this regeneration to happen at all, you need preserves of ancient forests free from any human interference. And I don't understand why. And then he goes on, efforts to offset the costs of protecting and restoring forests in the 21st century are happening around the world. And he's talking about this as like this really positive work that's happening. Some combine utility with education. Tourists in the Maya Biosphere Reserve in Guatemala employ residents who would otherwise be cutting down forests to sell lumber and to grow food in the clearings. And I was like, you're talking about indigenous people in Central America who've been working with the forests down there for a really long time and trying to get them employed at a job somewhere so that they won't be growing food in forest clearings. And I just didn't see that as very exciting at all. And I feel like he kind of had this idea that like the old growth forest is so pristine and perfect, and I'm just like, I don't care. I like just regular world, and I don't need it to be perfect. But he also had like things that I was like, I don't understand why he's saying that. So on 110 he says, it's bitterly cold in the winter, and sometimes water, he's talking about how trees shade streams, but how they do it in this way that's like really beneficial to the organisms there. Sometimes the water freezes solid, but it warms up only gradually in the spring. This habitat is not an option for many organisms, but pitch dark streams like this are rarely found in nature. So he's saying that if you have a stream, that it can get cold in the winter, but it shouldn't freeze too hard in the winter. And the way that won't happen is if you have deciduous trees lining the banks. And deciduous trees won't shade the stream in the winter, and so the streams won't get too cold and freeze too hard, which would damage certain aquatic life. And so I was in a totally different ecosystem. He's over in Germany, but like here, I look at all the gorges around Ithaca, and the streams there are always lined with hemlock. And hemlock is the darkest, deepest shade tree you can get. And I always thought that hemlock were really beneficial for the streams because they kept the water so cold. And people talk about when the hemlocks are faced with this huge pest now, and they talk about when the hemlocks go, that it's going to make trout populations suffer. But he's saying, but pitch dark streams are rarely found in nature because spruce don't like having wet feet and therefore keep their distance. It's most often plantations that cause this conflict between coniferous forests and the denizens of streams. And so maybe that's true in Europe, but it's definitely not true here. I'll just read a couple more. And then he says, but trees can't switch to winter mode yet for two main reasons. First, unless they are members of the cherry family, they use the last warm days of late summer to store energy. So he talks about the cherry family, which is the Prunus genus. That's like cherries, peaches, plums, apricots, all those trees. he talks about them going dormant really early. He describes that a lot. This chapter is called Hibernation, and it's about how trees go dormant. And he talks about how the cherry family goes dormant before anyone else. And I think that might be true where he is. I don't know. I've never been to Europe. But here, they're like the last ones to go. When I'm digging up my nursery, I always wait for the trees to go dormant, and the last ones are always all the prunus, all the cherry family. So I think there might just be a lot of differences between Europe and the United States. And then the last thing I want to mention, the last discrepancy I want to mention is on page 218, he's talking about immigrants. And immigrants are species that are not native, that have come in. And he talks about how the forests the old growth forests will prevent a lot of immigrants from coming in, a lot of non-natives. And I actually think that's fairly true. It's definitely not totally true, but you'll definitely get more non-native species in an area that's just met a bulldozer than you will in an area that hasn't been touched in 500 years. So he says, the same goes for, it would be so dark under the forest canopy that hogweed would disappear. The same goes for Himalayan balsam and Japanese knotweed, which also grow on riverbanks in the absence of forests. Trees could solve the problem if people trying to improve things would only allow them to take over. So in my stream, it's aligned with these old sugar maples, and under the sugar maples is the thickest Japanese knotweed patch you've ever seen. So I just didn't like that one either. All right. Actually, it's kind of funny. Overall, I did like the book. So I'm going to get back to just the overall summary of the book. In chapter 17, he talks about a beautiful concept about how trees create microclimates. And they actually created themselves by pulling water out of the ground and transpiring moisture through their leaves. And he talks about how most rain is from clouds that form over the ocean and then dump water. But he talks about how trees actually will kind of encourage this to go further inland into the continent, and how like the Amazon rainforest generates its own rainfall by all the trees sweating. And he describes it really well. And in chapter 27, he talks about, it's called Street Kids, and he's talking about city trees, and it was like the most depressing chapter. He just kept talking about how hard it is for these trees because they don't have the forest soils, they don't have the relationships with each other, they don't know where their mother trees are, and he basically made it sound like there's no point in having trees in the city, like they're just suffering and feel so bad for them. And I was like, well, what do you want us to do? So the last thing I want to say, because I feel like I'm taking a lot of time, is he in his last chapter, or one of the last chapters, it's called More Than Just a Commodity. And this was the first time in the book that he really so he spends the whole book kind of talking about like how incredible these trees are, how amazing they are when they can reach this long life, and how hard it is for them to get to this mature age. And it's always about like just keeping people out of the picture and letting the trees work it out, even if it takes them like 1,000 years. But then in the last chapter, he kind of starts to talk about like a vision for it. And I was like, finally, because I was like, how did you print this paper? Like, where are we supposed to get wood from? And then he kind of explains his vision, and I thought it was like really beautiful. So he talks a lot about how animal farming is transforming today. It used to be that nobody thought about animal welfare, and now you see like cage-free eggs or humanely raised meat or whatever, and how we're kind of trying to slowly switch out of factory farming into better systems of farming. And he talks about doing that with wood too, and treating the trees as we would treat like dogs or anybody, or cows. So it says, This means it is okay to use wood as long as trees are allowed to live in a way that is appropriate to their species. And that means that they should be allowed to fulfill their social needs, to grow in a true forest environment on undisturbed ground, and to pass their knowledge on to the next generation. And at least some of them should be allowed to grow old with dignity and finally die a natural death. What organic farms are to agriculture, continuous cover forests with careful selective cutting are to silviculture. In these forests, trees of different ages and sizes are mixed together so that tree children can grow up under their mothers. Occasionally, a tree is harvested with care and removed using horses. And so that old trees can fulfill their destinies, 5 to 10% of the area is completely protected. Lumber from forests with such specific species-appropriate tree management can be used with no qualms of conscience. So I thought that was really interesting. I had never thought of kind of treating trees like that. They should be allowed to have their own way of being, and then we carefully harvest. And that's this guy, Joel Salatin. He's this incredible animal farmer down south. He's written all these books, and he talks about if you take a chicken and you put it in a cage and it can't open its wings its whole life and it never sees the sunlight, it never got to express itself as a chicken. And they're he's the pigness of the pig. The pig wants to root in the earth. It needs to go outside and have fresh air and plants. And so that's what this guy's talking about. He's these trees need to be allowed to express themselves. Let's not just grow them in plantations or cut them ruthlessly. Let's allow them to communicate. We understand just a tiny bit of their communication, so let's let it happen. And I thought that was really cool. And I feel like the whole book was worth reading just to arrive at that last part. So that's all I'm going to say about A Hidden Life of Trees. And then I do want to say I wrote a book. It's called Trees of Power, and it's at the printers right now. It's being published, and I think it's going to come off the press in 2 weeks or something. But you can pre-order a copy if you want. There's cards there about it. And then I have a nursery. I raise all kinds of trees. Mostly I do fruit and nut trees and herbs and berry bushes. And there's cards there with information about our nursery. So if there's any questions, I can take some questions.
Thank you for your presentation.
All right.
I love your enthusiasm for the subject, your enthusiasm from the book, but now I'm going into how dumb am I. I just learned about mushrooms and trees recently.
Yeah.
How long has that knowledge been out there?
I think a while. I don't know how long, but I don't think it's new information. When I dig up a tree in a nursery, and I can see fungal strands all over the roots, and it's clearly not hurting it. I think people have known about it for I don't know when it was discovered. Yes, sir.
He's concerned mostly with monoculture, like beech forests or firs for wood pulp. What do you know about mixed forests like we have in the Northeast here?
What do I know or he know?
What do you know? What do collectively we know about?
We know just a little bit, right? He's mostly working with mixed forests in his woods. But I think what do we know is kind of we know a lot, but the more we know, the less we do. They're making discoveries all the time about the relationships that trees have with each other and with all these other organisms that are in the soil. They're talking about if you go and you take a teaspoon of forest soil from an old growth forest, there's thousands of different species in there, and they have predator-prey relationships, and they're looking at it with electron microscopes, and it's like the Amazon jungle in this little teaspoon of soil. There's so much life happening, and as these creatures are eating each other, they're pooping, they're peeing, they're decaying, and they're that's how plants are actually getting nutrients, is from the activity in the soil. And people are just figuring this out. And what do we know of those relationships? Nothing. There's a lot to learn. Did you have a question?
Yeah, I know one of the more interesting passages was about the
Yeah.
Tell that little story?
Yeah, it's really cool. He talks about, it's kind of like along the same lines as the Gypsy Moths. He talks about how the trees respond to being browsed on by giraffes, and they would, if the giraffes were eating on one acacia, the acacia would let other ones know, and then they would make their leaves like really unpalatable by like creating different chemical compounds in their leaves. So it seems like these trees are just standing there helpless. They're actually like doing things. We just can't see it, and like our perceptions of the universe are very small. And there's many layers to life that we will never see because we are limited by our 5 senses. But how many senses exist? I don't know. Yes, sir.
What kind of trees are they cutting down around here that are hauling away with the rough bark? I see a lot of trees that they're taking from this area.
Yeah, I mean,
What are they?
we have one of the biggest resources in our area is lumber. The cotton hamlin is one of the biggest sawyers in the area, and they harvest black cherry, white ash, sugar maple, white oak, red oak, like pretty much all the northeast forests are this is the second most diverse temperate forest in the world. The most diverse is in western China, and we have an incredible diversity here, and our hardwoods are like world class. Like our black cherry and our ash and our oak, it almost all of it is getting shipped to Japan. Cotton hamlin, I think they sell it all to Japan. So what species you're seeing, I don't know, but there's a lot of trees that get cut around here, and we have a ton of forests. We have like an incredible resource, and definitely not managing it nearly as well as we could. This guy.
Does the author get into the potential effects of global warming on the ability of forests?
I didn't talk about that, but he mentions that throughout the book about how trees respond to climate change and how they can mitigate it. He talks a lot about that, and he makes many different points about how helpful forests are in that regard, which I feel like is pretty obvious to most people if you think about the carbon cycle.
I used to live in another place than the present address, and there were 3 black, let's see, I'm forgetting the word.
Walnuts?
Black walnuts. And I think they put out a toxin that makes the soil inhospitable to other plants.
Right.
Especially tomato plants. I couldn't grow tomatoes. So is that generally true of trees, that they try to make the area that they grow in inhospitable to other species?
Sometimes, and sometimes they make it just more hospitable to their own species. But in the case of black walnuts, it's called juglone. It's the poison, and it only affects like certain things. It affects tomatoes. I think it affects like blackberries.
I know other things will grow there.
Yeah, it's not as long a list as you think. In fact, there's certain species that love black walnuts more than other places. So like black walnuts, you almost always find black-capped raspberries growing under them.
Yeah, raspberries.
Yeah, and it's weird. There's like certain plants that like it and certain ones that don't. But yeah, it can be. And then like some trees will actually kill earthworms. Black walnut will kill earthworms. The worm populations in spruce plantations is like 0. And yeah, the trees are doing the like an oaks the soil. It like changes it to a certain way, to like a certain flavor. But they all different species do that to a certain degree, and some are like really toxic. Like Norway maple is definitely like it doesn't let anything else grow there. It's called allelopathy, where they actually will poison other species, and some trees are better than that than others.
One more thing, not related to the book. Up at ESF in Syracuse, they're using a new CRISPR technology with gene editing to bring back the American chestnut tree. And it looks like they're going to be successful within another few years. It's really something.
That would be at least another hour. But that's like, it's so annoying to me because they already had a conventional breeding program that is restoring the American chestnut, and then they just jumped in and were like, we're gonna do it with GMOs, and it just looks so fake to me. I'm like, they already got it, why are you doing that? And it just looks like they're trying to say, look, genetic GMOs, we saved the species. That's kind of how I see it. It felt like totally unnecessary, like a huge waste of money. And they're trying to reintroduce those genetically engineered trees into the wild so that they'll mix with wild chestnuts and get it into the wild. And I'm like, are you sure you want to do that? It's a wheat gene that they put into these chestnuts. And now that's going to be in our wild population. I don't know. It would be another hour.
What about bringing the elm back?
Elms are coming back on their own and through the help of people. Yeah, there's lots of resistant trees that have been found. And you can go online and buy disease-resistant American elms. There's many cultivars and populations. I've found a few super healthy ancient American elms just driving around.
You want to comment on aspen groves?
What's that?
You want to comment on aspen groves?
Yeah, I could talk about aspens for a long time. In fact, one of the chapters in my book is just about aspens and how they grow. But I think I was supposed to stop at 1 o'clock, right? Should I take a couple more? Or?
You go ahead and take a couple more.
Okay.
Anything to say about the problem of forest fires?
He does talk about forest fires a little bit, and he talks about how fire suppression has caused the forest fires to be more devastating. And he talks mostly about how forest fires are really unnatural in his part of the world, and that they're almost always from like somebody's cigarette or something like that, because where he is, it's such a wet climate in Germany. Yeah. Well, I'll take one more. There was somebody over here.
I just wondered if you could tell us a little bit more about what your book is and how you came into this love of trees.
Yeah, well, it's a really long story, but I was really into wilderness survival for many years, and I felt like I wanted to connect with the earth. That was all I wanted to do. It was all I thought about, so I thought the best way to do that would be to like get rid of my clothes and make my own out of like buckskin and make a bow and like kill wild animals and eat wild plants and live in a hut that I made. And so I tried to do that, and I spent years trying to do that. I didn't have a phone or anything, and on one of my camping trips, I was deep in this wilderness area, and I had just come from Rochester, and in Rochester I had still been studying nature as intensively as I could, and there was so many animals in Rochester. Like the bird, it was in May, and the bird song would just be like enormous in the morning. You know, just the dawn chorus it's called. And there was, I would see raccoons, coyotes, foxes, rabbits, mink, all this stuff in the suburbs of Rochester. And then I went on this wilderness camping trip, and I was so far back. We had to canoe and then hike, and it was like nothing was there. There was like no birds. There was like one squirrel. There was no animals. And I was just starting to think like, maybe people aren't that bad. Maybe we can actually create habitat. We've done it on accident. Maybe we could do it on purpose. And what would that look like? And so that's what the whole book is about. Is about creating habitat on purpose and using different trees as our allies to do it. And so the book, I only wrote about 10 different species because there was so much to say about each one. So the first half of the book is about like different skills you can use or learn to work with trees, and then the second half is about the individual species and like how to use them specifically and how to work with them and as allies in this world. So yeah, all right. Thank you.
Thank you so much, Akiva. Akiva for a really fascinating and fun review, as well as showing incredible knowledge and enthusiasm. It was just really wonderful. Thank you so much. So, our Book Sandwiched In series has come to an end for another year. We are so glad that you have attended, and we hope you have enjoyed our presentations here at the beautiful First Congregational United Church of Christ facility. Thank you very much to the church for hosting us again this year. If you have suggestions for books or presenters for next year, please let me know by the end of August so the committee can make some decisions. You may contact me through the library. We will also be looking at the results of the survey that some of you filled out at earlier presentations to help us with our preparations. Mark your calendars for next year's offerings of Book Sandwiched in January and February. Again, thank you for coming. And as a special reward for your attendance, you will not have to put your chairs away. Aging in Place will have a presentation here tomorrow where Jenny Monroe will do a reenactment and trivia quiz about Mark Twain. You might want to come and participate in that. In any case, I hope very much that we will see you all next year. Thank you again to Akiva.